morning and hello everyone. So let's start with today's question. So today's question is single number 3. In the question, it is given that we are given an integer array where exactly two elements appear only once and all other elements appear exactly twice, right? So we have to find those two elements which appear once. This is our question. We have to write the algorithm in a constant extra space and linear runtime. Like we cannot use any extra space for a question, right? So let's see some examples. Here it is given that these are the numbers in the array. Now we can see the number 1 and 2 appear twice, right? So these are the numbers which appear twice, and 3 and 5 are those two numbers which we have to find and which appear only once in the array. So our answer will be 3 and 5, right? Now, if using an extra space was allowed, then we can simply use map, store the frequency of all the numbers, then easily we could find like how many numbers appear once and how many numbers appear twice, and it would be easy for us to figure out which are those two numbers which appear once, right? But here now we are not allowed to use extra space, so we have to do a question without using extra space, right? Okay. So let's start with the approach. Now just think, if it was given in the question that we have to find only one element which appear once and all the remaining element appear twice, then the question would have been very easy and we could simply use the XOR operation, where if we will take the XOR of the entire array, then the number which appear twice will become 0, right? Because XOR of the number will itself is 0, as I have told you in the previous videos also. So the after taking the XOR of the entire array, we will be left with the element which appear only once. This would be the single element, but here in our question we have to find the two such element which appear once, right? So if you will take the XOR of the entire array, you will left with the XOR of those two target elements, right? So let me explain you here. Like suppose I am given array like this, 3. Okay, so this is our array. Let us short it first. So this is like this. Okay, so now as I'm telling you that we can take XOR of the entire array. So if you take XOR, then 1, XOR 1, XOR 2, XOR 2, XOR 3, XOR 5, right? So this will be the XOR. Now on taking XOR of 1 with 1, it will be 0. Okay, on taking XOR of 2 with 2, it will be 0 and I will be left with this. So this is basically 3 XOR 5. So after taking the XOR of the entire array, we are left with, let us suppose it comes out to be X something. Okay, so after taking XOR of the entire array, we are left with a particular single element which is a XOR of the two target elements, right? So in this way you cannot find the two elements separately, because in the answer we have to return the two elements separately, right? So we cannot find this way. It was valid only for the question where we have only one element which appear once and all other elements appear twice. So here we are getting the XOR of the two target element. Now if you want to find the two target elements separately, then how will you approach the question? So let's think about it. Now, as you know, let us suppose I'm given two numbers. So our 3 is 0 0 1 0, right? And our 5 is 1 0 1, something like this is the binary representation. Okay, this is our, I guess, 0 1, no, this is 3. Okay, so sorry, this is our 3, this is our 5. Now on taking XOR of these two numbers, you will get something like 1 1 1 1 0. Okay, so now this will be the final number we will get as the answer after taking XOR of the entire array. Now let's see what happened. Now you can see when we take XOR of a particular bit, then if the two number having a different bit at the ith position, then the XOR of the two number will have 1 at the ith position, right? So if I'm getting 1 at this particular position, then I am sure that both the number which I'm taking XOR of will have a different bit at that particular location. Okay, like here you can see there 0 and 1. That's why I'm getting 1 here. Here also if I'm getting 1, then you will have 1 here or 0 here, or maybe vice versa. Now if I'm getting 0 here, then I'm pretty sure that the both the number will have equal bit at that particular location. Like here you can see if I'm getting 0, then both have 1 here. Okay, so particularly we have to find the first point of difference, so first position of difference where both of these two numbers differ in their bits, right? So let's start from the rightmost side. If I'm starting from the rightmost side, then both the number have a bit 1. Then we will move to the next position. Now this particular position is the first point of difference where the bit in both the number differs, right? So we will firstly find that particular position, like which is the position where I'm getting the first different bit for both the numbers. Okay, now after finding that particular position, I will divide the entire array into two groups based on that particular position, right? Like suppose I am getting the different bit in the two target number at ith position, right? So I will divide my array into two groups where first group will contain the number which have the bit 1 at the ith position, and the second group will contain the number which have bit 0 at the ith position. Okay, so now if we have all the if the number is appearing twice in our array, then it will definitely both the both the occurrence of the number will definitely belong to the same group, right? And if the number is appearing once, then it will only have a one occurrence. So if I'm getting a group 1 and group 2, and in group 1, suppose, just I'm throwing an example, this is not surely right. Okay, so suppose in group 1 I have something like 1 1 and 3. Okay, and suppose in group 2 I have something like 2 2 and 5. Okay, so now in group 1 we have 2 1 and 1 3. In group 2 we have 2 2 and 1 5. So on taking XOR of the all the element of the group 1, you will simply get 0 XOR 3, which is definitely equal to 3. Now you will here get 0 XOR 5, which is definitely equal to 5, because XOR of 1 by 1 and 1 will be 0 and XOR of 2 and 2 will be 0, right? So after taking the XOR of the group 1 and group 2, you can definitely find the two target element individually or separately. So this is a approach which we are going to follow. In this way we can find both these elements separately and we can return it as an answer. So I hope you get the approach. Basically we are, first of all, we are taking the XOR of the entire array. After getting XOR of the entire array, we will get the XOR of the two target element, right? Now, with the help of XOR, we can find out the first position where the bits in the target element are different, because if the bits in the target element are different, then the XOR will have 1 at that particular location, right? This is something which you understand, I hope. Okay, so if there is 1 at XOR, then I am sure that the bit in the two numbers at that particular location will be different. So once I find that position, I will divide my array into two groups on the basis of that position. If the bit at that particular position is 1, then I will put all those numbers in group 1, and if the bit at that particular position is 0, then I will put all those numbers in the group 2. Now I am separately taking the XOR of group 1 and group 2, and after getting the XOR of group 1 and group 2, I will left with the two target element which I want as my answer. So let's write the code now. Just a minute. Okay, so what was our first task? It was about taking XOR of the entire array. So after taking XOR of entire array, we will get the XOR of the two target element, right? So let us suppose XOR is 1 initially. Now I'm taking XOR of the entire array. So XOR, right? So this will be the XOR of our entire array. Now once I find XOR, I will find the first point position of difference. First position of difference, right? Like the first position where both the target element will have a different bit. Okay, so on how to find the first position of different, we will simply you know run a loop, and I will check if the bit at that particular position is 1 or not, because bit at that particular position in XOR is 1, then this is a required position, right? So I will check if bit at that particular position is 1 or not. If it is 1, then I will simply break from the loop. If it is not 1, then I will increase my different bit by 1. Okay. So basically this is the index of the different bit which I am storing in a different bit now, and I will shift my XOR by 1 position. Okay. So this way I will be able to find the first position of difference. Now once I find that particular position, I have to divide the array into two groups, right? So let's say group 1 XOR I will be storing in XOR 1, and group 2 XOR I will be storing in XOR 2. And initially both of them are 0. Okay. Now I have to check whether the element in nums belong to the group 1 or group 2. Okay, so if bit at that particular position, right? So after shifting IT with differ bit, and then taking AND with 1, sorry, and then taking AND with IT, if I'm getting 1 out of it, then definitely it should belong to the group 1. So group 1 XOR equal IT, otherwise I will XOR it with group 2 XOR equal ID, right? And I am just returning the XOR 1 and XOR 2 because this will be our final result or the target number which I had to find. So these are our two target numbers. Okay, so it's working fine, right? So this was the entire approach which we followed. Now if you have any doubt, so just let me explain you this operation if you didn't understand. Actually, what does this operation actually mean? Just a second. Okay, so it is checking if the um, bit at the ith position, if the bit at the ith position is 1 or 0, on the basis of that we will just put that particular element in group 1 or group 2, right? This was our aim. So now I'm just shifting my 1 by a differ bit. Like differ bit is a position where we have to check, right? So I'm just right shifting my 1 by that bit. I'm just left shifting my 1. Okay, so 1 is like 0 0 0 0 0 continual 1, right? This is our 1. And now if I'm shifting my 1, if I'm left shifting my 1 by, let's suppose 4 position, then it will be like 0 0 0 0 1 this way. Okay, so this will be our 1. And now if I'm taking is and with some number, say anything 7, so I will get the bit I will get whether the bit at the fourth position in 7 is 0 or 1, right? So this was the way of finding, like bit at the ith position in the particular element is set or not, and on the basis of that we will divide them into two groups and then weigh it against it. Okay, so I hope you guys got the solution well. If you have any doubt or query related to the question, or if you have not understood the problem or the solution, then you can simply ask in comment box. I will solve it.